Hi guys, welcome back. Today we are going to learn to use iteration to find approximate solutions to equations. We've got 4 success criteria, and the first one is to be able to use trial and improvement. So trial and improvement involves using the result of a previous trial to obtain a more accurate answer. So this question says the equation x cubed minus 3x equals 41 has a solution between 3 and 4. And we want to use trial and improvement to find the solution to one decimal place. So this means this equation has an x value that's between 3 and 4. So we want to find out what that x value is to one decimal place. So let's start by trying a number in between 3 and 4. So the number directly in between 3 and 4 is 3.5. So we substitute that into our equation, and we want to get an answer that's as close to 41 as possible. So the answer to 3.5 cubed minus 3 times 3.5 is 32.375. So this is below 41. So 3.5 is too small. So we're going to try a number bigger than 3.5, but still between 3 and 4. So I'm going to try the number 3.8 and see what this answer gives me. So if I substitute 3.8 into the equation, I get an answer that's 43.472. So this is bigger than 41. So 3.8 is too big. So I'm going to try an answer that's less than 3.8, but bigger than 3.5. So I'm going to try 3.7. So I substitute in 3.7, and I get an answer that's below 41. So this means 3.7 is too small. So my answer is in between 3.8 and 3.7. And I want to give my answer to one decimal place. So I need to find out whether it's closer to 3.8 or 3.7. So I'm going to substitute in the number 3.75. This gives me an answer that's bigger than 41. So 3.75 is too big. So if I use a number line, the number to one decimal place needs to be below 3.75. So my final answer needs to be 3.7. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. Okay, so for this question, we're going to start by substituting a number that's in between 6 and 7, so 6.5. When we substitute in that number, we get an answer that is less than 112. Remember, we want our answer to be as close to 112 as possible. So 6.5 is too small. So next we're going to try 6.8. And if we substitute in 6.8, then we get an answer that's bigger than 112. So 6.8 is too big. So next I would try 6.7, substitute 6.7 in, and I get an answer that's below 112. So 6.7 is too small. So again, my answer is in between 6.8 and 6.7. So now we're going to try 6.75 and see whether it's closer to 6.8 or 6.7. When I substitute 6.75 in, I get an answer that's bigger than 112. So this is too big. So to one decimal place, my answer is 6.7. Here are 3 questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answer, there's your amber answer, and there's your red answer. And now we've completed success criteria 1. So now we're going to move on to number 2, and this is to rearrange formulae into iterative formulae. So to be able to use the iterative process, we need to be confident with rearranging formulae. So if you're not confident with rearranging formulae, have a look at our video on rearranging formulae, the higher version. So iteration is the act of repeating a process with the aim of approaching a desired solution. Each repetition of the process is called an iteration. So iteration is a way of solving equations, and it's used when you can't solve the equation any other way. An iteration formula would look like this. This means the next number in the sequence, n plus 1, is 4 times the previous term, n, and add 1. We're going to look at how to use an iteration formula later in the lesson, but first we'll look at how to form an iteration formula. So we want to rearrange the equation x cubed plus 3x minus 1 equals 0 into an iteration formula. To make an iteration formula, we rearrange to get one of the x terms on the left-hand side. So to do this one, I'm going to add 1 to both sides. Then I'm going to subtract 3x from both sides. And then I'm going to cube root both sides. So now the left-hand side is just x, and the right-hand side is the cube root of 1 minus 3x. At the end, swap the x terms for xn plus 1 and xn. So our final answer looks like this. There are 2 possible iteration formulas that can be made, and this time we will get the other x on its own. So again, on this one, I'm going to add 1 to both sides. Then I'm going to take away x cubed from both sides. And then I'm going to divide both sides by 3. So we've now got x on the left-hand side on its own, and on the right-hand side, we've got 1 minus x cubed over 3. So our final answer is x n plus 1 equals 1 minus x cubed n over 3. Often, the question will tell you what form is needed. So for instance, a question like this. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So this question says, show that x cubed plus x squared minus 5 equals 0 can be written in the form x equals the square root of 5 minus x cubed. So to start with, we're going to subtract x cubed from both sides. Then we're going to add 5 to both sides. And finally, we're going to square root both sides. And there's our final answer. Here's some questions for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. Here are your answers. And now we've completed success criteria 2. So now we're going to move on to number 3, and this is to use iteration to find approximate solutions to equations. So this question says use the iteration formula xn plus 1 equals the cube root of 2xn squared minus 5, with x0 equals minus 1, 4 times to find the value of x4. So step 1, type the value of x0 into your calculator and press equals. So on our calculator, we're going to type in minus 1, then press equals. Then step 2, type the right-hand side of the iteration formula into your calculator, swapping xn for ans. So we press shift, then the cube root button, then 2, then ans squared, and then take away 5. If we press equals, we should get this answer. Now this is the value of x1. If we press equals again, then we get the value of x2. If we press equals again, we get the value of x3. And if we press equals again, we get the value of x4. So that's our final answer. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So for this question, the question says by taking x0 as equals 0, use the iteration formula xn plus 1 equals 8 over 9 minus xn cubed over 9, 3 times to find the estimate for the solution x cubed plus 9x equals 8. So if we start by taking x0 as 0, then x1 will be 8 over 9, x2 will be that number there, and finally x3 will be that number there. Let's have a look at this example. So by taking x0 as 1, use the iteration formula xn plus 1 equals the cube root of 4xn minus 1 to find approximate solutions to x cubed minus 4x plus 1 equals 0, correct to 3 decimal places. So we know that the first iteration is 1, so that means the next iteration will be that number there, so x1 equals that number. x2 will be that number there. x3 will be that number there. x4 will be that number. x5 will be that number. x6 will be that number. x7, x8, x9, x10, x11, and you can see to 3 decimal places the number starts to repeat itself. So that means we can round our answer to 3 decimal places, so x is 1.861. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answer, there's your amber answer, there's your red answer, and there's your purple answer. The word convergent means the answer approaches and a limit will be the same number. Divergent is when the answer does not tend to a limit. So that means it keeps changing. So show that using x0 equals 2, that xn plus 1 equals a quarter of xn cubed plus 1 leads to a divergent sequence. So if we start by substituting 2 into this equation, we get 2.25. And then if we substitute 2.25 into that equation, we get 3.097. And if we substitute that, and you can see that the amount just increases each time. It doesn't converge on a particular number. So this is divergent. Here's some questions for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So here are your answers. So you can mark those. And now we've completed success criteria 3. So now we're going to move on to number 4, and this is to apply iteration to problem-solving questions. So finding roots. So show that the equation x cubed plus 4x equals 1 has a solution between x equals 0 and x equals 1. So here's the graph of x cubed plus 4x. And there's the line y equals 1. So they have a solution, they meet, the two lines cross there on the graph. So that is in between 0 and 1. So we can show this using iteration. So if we start with x equals 0 and substitute that number in, we get 0. And then if we substitute x equals 1, we get 5. So one answer is above 1 and 1 is below 1. So this implies there is a solution between x is 0 and x equals 1. This time we want to show that the equation x cubed plus 5x equals 73 has a solution between x equals 3 and x equals 4. So if we substitute in x equals 3, we get 42, which is below 73. And if we substitute in x equals 4, this gives us 84, which is above 73. So to get an answer of 73, we'd need to substitute an answer in between 3 and 4. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's the green answer, there's the amber answer, and there's the red answer, and there's the purple answer. So now we're going to have a look at some worded problems. So the number of bees in a beehive at the start of the year N is Pn. The number of bees in a beehive at the start of the following year is given by the equation Pn plus 1 equals 1.05 times Pn minus 250. At the start of 2015, there were 9,500 bees in the beehive. So how many bees will there be in the beehive at the start of 2018? So use the starting value that is given and then work out how many iterations are needed. So in 2015, P0 was 9,500. So that means in 2016, using iteration, P1 is 9,712.5. In 2017, P2 is 9,935.62. And in 2018, P3 is 10,169.90. So our answer is 10,169. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answer, there's your amber answer, and there's your red answer. And now we've completed success criteria 4. So now that we've completed the last objective, it's time to end the video. Hope you enjoyed it and hope you found it useful. Make sure to like and subscribe and be sure to check out the other videos on the rest of the channel. I'll see you next time. See ya.